Okay, so this is a short video about how to use the storyboard method in order to process a titration question. A problem which a lot of students have is not that they don't understand the moles equals CV or moles equals mass over MR, and not that they don't know how to use a calculator, is that we don't process the question and make sure we can picture it in our head. With a titration, you have to be able to visualize what's going on, otherwise you'll end up using the wrong number for the wrong chemical. So the way to do that is one sentence at a time, you're going to convert the question into a little storyboard. Now, if it is a titration, you're always going to have a burette, which kind of vaguely looks like that. And that's going to be into a conical flask or some other kind of vesicle. So you can start your storyboard by drawing that. The titration will always include that. Sometimes, if there's a sample, there will be a volumetric flask beforehand. So you'll have to check the question for that. So your storyboard, your diagram, is going to look like this. If it's a particularly gnarly question, there might be one more step beforehand. But like 99% of the time, it's going to look like this. So what we're going to do is we're going to go through the question one sentence at a time, and we're going to write down which chemical is where, in which bit of equipment, and what we know about it. So, sentence number one, a chemist had 250 centimetres cubed of nitric acid. Now the thing that's 250 centimetres is going to be in the volumetric flask. You can get other sized volumetric flasks, so you can get 100 centimetres, 150, but the 250 is going to be in the volumetric flask. So I can put a little title, nitric acid, so I know what chemical's in there, and I'm going to say what I know about it. Well, I know it's 250 centimetres cubed. Very important we put the units on, so when we look back at this later, we know what that number means. If I just start writing down random numbers with no units, it's not going to mean anything to me later on. It then says we took a 25 centimetre cubed sample of this. So the next video in your task list for this is samples. But what a sample is where you have a large volume of something and you take out a smaller volume. So we've taken out 25 centimetres cubed. Now we've got to be really careful here, because sometimes you're going to put your sample in the burette and sometimes you'll put it in the conical flask. Now it says here that we are titrating this against the potassium hydroxide. And so we know our sample is going to go in the conical flask. Usually what we put inside the conical flask will be 25 centimetres cubed, because the measuring pipettes are usually 25 centimetres cubed. But again, not always, so you do need to double check. So this is a sample we've taken here. It's worth writing that down so we know. So what do we have in the conical flask? We have nitric acid, and we know that that is 25 centimetres cubed. It then says we're titrating this against 0.5 moles per decimetre cubed of potassium hydroxide. So in our burette must be the potassium hydroxide, and that is 0.5 moles per decimetre cubed. And it says the tetra was 23.5 centimetres cubed. Again, if you're not sure what the tetra is referring to, well, is this the volume of the potassium hydroxide or of the nitric acid? Well, there's two clues there. The lesser clue is that we already know the volume of the nitric acid. But the bigger clue, and the thing to kind of remember, is that the meaning of the word tetra is the volume that was used from the burette. So the tetra is always the volume of the thing in the burette. That's something to definitely remember. And then the question asks us to find the mass of nitric acid in the original solution, which would be the 250. So I'm going to say mass equals question mark. That's how we process the question. Can you see how much clearer it is now what's going on? We've got a large volume of nitric acid, we've taken out a smaller volume, we've titrated it against some potassium hydroxide. And your diagram's always going to look very, very similar to this. If there's no sample, you won't even have this stage, so it'll be even simpler. Very occasionally, there'll be something beforehand, so read the question. That will really, really help you when you go to do the maths side of this question.